Hi, welcome to the revised help for Coding Program 3, The Planets. This revision takes into consideration how we're going to handle calculating the travel time. Okay, so as you can see, I have created my project Nelson P3, and I've added a driver to my project. I have my name, email, title of my program, and my file name. I've already written my pound includes. I'm including IOStream for C in and C out, IOmanip for formatting if I want to use it, string, which I need for string, and vector to be able to use the vector class for storing the planet data. And again, using namespace standard. I have started my program int main and ended it with return 0, and everything else goes in the middle. So what am I going to do first? I'm going to declare some variables and create vectors. Okay, so what variables am I going to need? When we look at the spec, we see that we're going to need the user's name, the Earth weight, the speed to travel, and the planet that the user might want to visit. So I'm going to create some variables, and if I need more, I can always add them. Double weight is going to be the weight on Earth, and then new weight will be the weight on the new planet. I'm going to create some ints. Planet will be the index of the planet. Speed will be the speed that the user is traveling. And years, days, and hours have to do with the travel time, which I'm also going to include. Name and continue, or cont, which I'm going to use, for my play loop, okay? So I have a couple of constants I'm going to add that I'm going to need in my calculation for years, days, and hours. And those are constant int, int hours to years is 8760. Where does that number come from? It's 365 days in a year times 24 hours in a day. And then I'm going to need hours to days. That one's easy, that's 24. Okay, so let's continue declaring variables, because after all, we are going to create objects from vectors. So those will be vector objects. And those are actually variables of a different type. So let's start out with a vector of strings, which will be the planet name, and a vector of doubles, which will be its relative gravity. And finally, we come across the kind of difficult vector, and that is the vector of something for distance from sun. And the reason this is a problem is that we would like to use an integer, but if you look on the, let's see, here's the spec, and it gives us the values to use. We find the Neptune is 2,793,000,000 miles away from the sun. Now, why is this a problem? Well, the largest integer, if we just use an int, that we can represent is 2,147,483,647. So the distance to Neptune is larger in integers than the largest integer we can represent. So we need to use a different data type. We can use an unsigned int. The reason we can use an unsigned int is that all of the storage for integer goes on the positive side of the line with unsigned int because no negative numbers are allowed. And so the largest number for an unsigned int is 4,294,000 and some. So that would be big enough. We can use a long, which is a 64-bit number, which is huge, and it will certainly contain our number. We can also use a double, and doubles go up to e to the 308th, which I think is probably pretty safe. So I'm going to use doubles, and we're just going to have to cast them into ints later on when we need them. Okay, so we have declared our variables, and now we have to add their values. Put values into the vectors. Now what we're doing is we have three vectors that are describing the three attributes for each planet. We have the name of the planet that's going to go in planet name. We have the how far away it is, which is going to go in distance from sun, and then percent of Earth's gravity, which is going to go into relative gravity. So we need to put all of these values in exactly the same order, and that way the planet name will correspond to the correct relative gravity and the distance from sun. So let's put a few values in there. Planet name, and the way we do that is we use something called the pushback function in vectors. That means we're adding this to the end of the vector. When we create this vector like this, there's nothing in it. So now this is how we build the vector, and the first planet's name is going to be Mercury. Make sure you put Mercury in double quotes, because that means it's a string literal, and that's its name. And then the next one will be Venus. Okay, and so on. So we will go all the way through to Neptune. Now we're going to look at relative gravity, okay, and try to spell it correctly, which I didn't. So we're going to push back on that vector also, and the relative gravity for Mercury is 0.27. Well, that was easy. And then the relative gravity for Venus is 0.86. And then we will fill up the rest of the vectors. Finally, we get to the vector of doubles, which is distance from sun. And it's not distance, it's dist. There we go. Push back, and this time we can go ahead and put the full number in. So let's see, that's going to be 36 million miles. And even though this is an integer, you know what, you can put a dot there. So now we are adding, we are putting in a double. And distance from sun, push back, for Venus is 67 million miles. Okay, so we have more of those to add as well. So we're pretty well set up. Now it would be a good idea to see out your header. Okay, and we all know how to do that. I don't have to show you. And now we are going to get information from the user. So what am I going to do? I'm going to see out. Please enter your name. Okay, that's pretty reasonable. And I'm going to just put another \n at the end because I like the cursor to go back to the next line and let the user enter there. Now, should I use a CN or a get line? Well, if your name is Bob Jones and you only enter Bob, then you can use CN and it will work fine. But if you enter Bob Jones, you better put in a get line because you need to have both names. CN will only read to the first white space and then stopped. Jones will be in there and it will be read in your next question. So I'm going to use get line, and I think my variable name is name. Yep, it is. Okay. Now I'm going to find out the weight. Please enter your weight. And this time it's just going to be a number, so I can CN weight. And when I do that, because I'm using get lines over here, I need to use a CN.ignore. When I CN weight, what happens is, what does the user do? The user types in, I don't know, 125 pounds and then enter. CN reads the 125. It does not read the enter key. So the next time you use a get line, it will read the enter key and think it is finished, because that's what the get line does. It reads up to the whole line until the enter key, and then reads the enter key and discards it. So in order to read properly next time, you're going to need a CN.ignore here. Okay, so now it's time to open our play loop. So that this is asking and calculating the travel speed and the chosen planet. So we're going to ask for the speed to travel, okay? And then we're also going to say choose, whoa. Okay, this is not a good spelling day for me. Choose your destination. Destination. Okay. And how are we going to do that? Well, I am going to show a menu. And this is how I'm going to do it. I'm going to use a for loop, and I'm going to loop through all of my planet names and display them to the user. I'm going to start at 0 because we're in a 0 indexed. I is less than, how many planets do we have? 8 plus I. Or I plus plus. Both of those work. Now I'm going to see out planet name dot at I. Well, that's pretty good. And I'm going to have an end line at the end of that. End line is just like \n, except it's at the end of the line. Okay? And sometimes it's convenient to use that. Now, if I do this, the user is going to look at the planet name, and they're going to have to enter the planet name. This gives them the opportunity to misspell it, to use a cap or not, whatever. So what we're going to do is add a number for them. So I'm going to see out I plus 1, and I think I'm even going to put in a period. So what does this do? This gives me, when I equals 0, it's going to be planet number 1. When I equals 1, it's going to be planet number 2. So it's going to be 1 period, 2 spaces, and the planet name. So that's kind of neat. It looks like a menu that they can use. And then I'm going to say enter your number choice. And I'm going to cin planet. Cin dot ignore. Okay, now, and there we go. All right, now planet is supposed to be the index in the vector of which planet they've chosen. If I use this value of planet, instead of being from 1 to 7, it's going to be from 0 to 7, it's going to be from 1 to 8. So I need to modify planet. And I'm going to do that by subtracting 1 from it. Now, make planet 0 indexed. Okay? All right. Well, so far so good. We've gotten all the information that we need, and now we need to calculate travel time and the new weight on the planet. We can do the new weight first. It's a little simpler. New weight is equal to weight times what? It's going to be times the relative gravity, isn't it? So there's the relative gravity vector at whatever they've chosen, planet. Okay, so now you have the new weight. So the travel time is the distance to the planet. So divided by the speed. Okay, so how long it takes to travel that distance. So I'm going to make just a small local variable, double distance. Okay, the distance to the planet from Earth is the distance from the sun at the planet they've chosen, okay, minus the distance from the sun at, what is Earth? Mercury is 0, Venus is 1, and Earth is 2. Okay, so that gives us the distance. Travel time is going to be equal to distance divided by speed. Okay, and I'm pretty sure we already asked for speed up here. Okay, I'm going to let you do that. The only thing is, distance is a double, speed is an integer, and travel time is an integer, and we want travel time to be an integer. So what are we going to do? Yep, we're going to cast, why did I do that? There we go. Static cast int the distance divided by the speed. There we go. All right. So now we have travel time. We need to figure out, okay, this is in hours, and it's going to be a lot of hours. Figure out travel time in years, days, and hours. That's like saying, okay, my birthday is in 2 months, 3 weeks, and 5 days. Okay, except we're just going to do years, days, and hours because they're very large numbers. Now, the way we figure out years is to do integer division. Years is equal to travel time divided by one of our constants, which is hours to years. Okay, so that's going to give us how many years that it will take to get there. Now there's going to be some hours left over. Hours left is equal to travel time mod hours to years, because the modulus function is there to give us the remainder of an integer division. Okay, so we have years and then some hours left, and we want to find out how many days that will be. So that's hours left divided by hours to days. Okay, and again, we're going to have, oh, I didn't do a good job on that. Those should be all caps. Shame on me. Let's fix that. That's 2 points off, you know. Yikes. There we go. Okay, so again, we're using integer division, and we're going to have some hours left over again. And that's going to be hours is hours left mod hours to days. Okay, so we have years, days, and hours now. What's left is our output. Let's do set precision first to two decimal places. Okay, you know how to do that. And then we're going to see out, and I'm just going to comment this, name, wait on Earth, wait on new planet, oh brother, okay, chosen destination, travel time in years, days, and hours. Okay, so this is actually a comment all over. You're going to create that, and it's going to be a long string, and you might have several couts. Okay, and then we're going to ask if user wants to travel again. And in my case, I'm going to getLine, cin cont, which is going to be either I'm going to say yes or no. And right here, I have to finish my do while loop. See, I started it up here. And it's going to be while cont is the same as yes. We will continue. And when it's not, we're done. And down here, we're going to say goodbye when the user is finished. Okay, so that's the help for program 3, the Planets program. If you have any questions, email me, and see you next time.